Ever wondered how data is transmitted smoothly and accurately over networks? The answer lies in data link protocols. These protocols set the rules and procedures for data transmission at the data link layer, also known as Layer 2 of the OSI model. They're the virtual conductors of the digital orchestra, ensuring node-to-node communication, framing, error detection and correction, as well as flow control. Imagine a complex ballet of data where every movement is precisely choreographed to ensure that information is delivered exactly as intended, from one point to another. This ballet would be impossible without the right protocols. And in the realm of computer networks, two dancers often take center stage: the high-level data link control, or HDLC, and the point-to-point protocol, or PPP. But what makes these two protocols stand out from the crowd, and how do they differ from each other? Two of the most widely used data link protocols are HDLC and PPP, but how do they differ and what makes them unique? Let's delve into the world of HDLC, the bit-oriented protocol that has set the stage for reliable data communication. High-Level Data Link Control, or HDLC for short, is a brainchild of the International Organization for Standardization. It's a framework that paves the way for reliable data communication, whether point-to-point or multipoint. HDLC's key features are as intriguing as they are crucial. Let's start with the fact that it's bit-oriented. This means that HDLC operates at a level where data is transmitted and controlled through bit sequences, the most fundamental units of data. Next, we have framing. HDLC uses a standardized frame structure to encapsulate data. These frames start and end with a unique flag pattern, which is 011111110. This allows receivers to identify individual frames and makes the data transmission process smoother and more organized. But what happens when errors creep in? That's where HDLC's error detection feature comes into play. HDLC incorporates a cyclic redundancy check, or CRC, to detect errors within frames. This helps maintain the integrity of the data being transmitted. Then there's flow control. HDLC has various flow control mechanisms up its sleeve to manage data transmission rates and prevent buffer overflow. This ensures that the data doesn't come in too fast for the receiver to handle. HDLC also has three modes of operation. There's the normal response mode, or NRM, used in multipoint communication. Then there's the asynchronous response mode, or ARM, which is similar to NRM but allows secondary stations to initiate communication. Finally, there's the asynchronous balanced mode, or ABM, used in point-to-point communication and lets both stations initiate communication. HDLC is commonly used in wide-area network technologies where reliable point-to-point or multipoint communication is required. Moreover, it serves as the basis for other data link protocols, including PPP and frame relay. HDLC is a robust and flexible protocol, providing a foundation for many WAN technologies and other data link protocols. Now, let's explore the point-to-point protocol, or PPP, a protocol designed specifically for direct connections between two nodes. PPP operates at the byte level, which means that it deals with data in terms of byte sequences rather than bits. This is one of the key distinctions between PPP and HDLC. It's like dealing with words instead of individual letters, which can make the process more efficient. When it comes to framing, PPP frames start and end with a unique flag character, much like HDLC. However, PPP also incorporates escaping mechanisms to ensure that the data within the frame does not inadvertently contain the flag pattern. This safeguards against misinterpretation of data as frame boundaries. PPP is not just about sending data though, it's also vigilant about data integrity. It incorporates a frame check sequence, or FCS, to detect any errors within the frames. The FCS typically uses CRC16 or CRC32, which are common methods for error detection. But PPP doesn't stop there. It goes a step further with unique features like authentication. It includes protocols such as the Password Authentication Protocol, or PAP, and the Challenge Handshake Authentication Protocol, or CHAP. These protocols validate the identity of the communicating nodes, ensuring that the data is being exchanged between the right parties. Another notable feature of PPP is protocol multiplexing. This means that PPP can support multiple protocols over a single point-to-point link. This versatility allows different types of traffic to be transmitted at the same time over the same connection. Finally, let's talk about the role of the Link Control Protocol, or LCP, and Network Control Protocols, or NCPs, in PPP. The LCP is used to negotiate and establish the parameters of the link, such as authentication and compression. The NCPs, on the other hand, are used to configure network layer parameters, like IP addresses. From dial-up connections to VPNs, the point-to-point protocol's versatility in handling different types of traffic, its robust authentication mechanisms, and its ability to configure link and network parameters make it a popular choice for many point-to-point network connections. Now that we've explored HDLC and PPP individually, how do they stack up against each other? Let's start by looking at their key features. Both HDLC and PPP are bit-oriented protocols, transmitting data in bit sequences. They both use a unique flag pattern to frame the data and incorporate error detection mechanisms such as cyclic redundancy check to ensure accurate data transmission. However, there are a few key differences. For starters, HDLC operates at the bit level, while PPP operates at the byte level, with frames consisting of byte sequences. This means that PPP can handle larger data units, which can lead to more efficient data transmission in some cases. Another significant difference lies in their flow control mechanisms. While HDLC supports various flow control mechanisms to manage data transmission rates and prevent buffer overflow, PPP does not explicitly include flow control. However, PPP compensates for this by incorporating features like authentication and protocol multiplexing, which are not present in HDLC. Moreover, HDLC supports different modes of operation, including normal response mode, asynchronous response mode, and asynchronous balanced mode, depending on the communication requirements. On the other hand, PPP is specifically designed for point-to-point connections, making it ideal for direct connections between two network nodes. When it comes to their applications, HDLC is commonly used in WAN technologies, where reliable point-to-point or multipoint communication is required. It also serves as the basis for other data link protocols, including PPP and frame relay. PPP, meanwhile, is often employed in dial-up connections, DSL, VPNs, and other WAN environments, making it a versatile choice for different network configurations. In conclusion, while HDLC and PPP have some similarities, they were designed with different use cases in mind. HDLC's flexibility makes it a great choice for various communication requirements, while PPP's focus on point-to-point connections and additional features like authentication make it a robust choice for direct network connections. While both HDLC and PPP have their unique strengths, they both play a crucial role in ensuring smooth and accurate data transmission. So, we've taken a deep dive into the world of data link protocols, exploring HDLC and PPP. We've uncovered how these protocols operate at the data link layer, enabling reliable node-to-node communication, error detection and correction, as well as flow control. We've seen how HDLC's bit-oriented nature and unique framing mechanism make it a robust choice for WAN technologies. Simultaneously, PPP's byte-level operations, authentication capabilities, and protocol multiplexing make it a versatile option for direct point-to-point connections. The difference between them lies in their operational details, with HDLC providing a framework for both point-to-point and multi-point links, while PPP is designed specifically for point-to-point connections. Whether it's HDLC's robustness or PPP's versatility, data link protocols are the unsung heroes of network communications. Thanks for joining us on this journey into the world of data link protocols. Until next time, keep exploring.